Hello, and welcome to the Dirty Mess, also known as my garage. Today we're going to be talking about thrust bearings and their failure, which is commonly known as crank walk. So let's start off by talking about what a thrust bearing is and what it does. This is a thrust bearing. It's located usually at the rear or in the center of an engine under the main bearing cap, and its job is to locate the crankshaft longitudinally. So when an engine's running and the piston's going up and down and the force is spinning the crankshaft, it's also trying to force the crankshaft towards the rear of the engine. And conversely, when you engage the clutch and the throwout bearing presses upon the fingers on the pressure plate, that puts force against the flywheel, or in the case of an automatic, the torque converter on the flex plate, that tries to push the crankshaft forward. So the job of the thrust bearing is to absorb those forces and keep the crankshaft centered in its place. Now, crankshaft failure, also known as crank walk, the symptoms can range from a rattling noise or a clunk to hard shifting, starting, and even stalling when you have the clutch pressed down. This can lead to crankshaft or main cap or even block damage. It can also lead to failure of connecting rods from the sideways force put on them. Now, it's usually caused by either a loss of lubrication, just like any other bearing, or improper loading, such as improper throwout bearing adjustment or riding the clutch. In the case of automatics, it can be high line or torque converter pressure, and that can be caused by incorrect throttle valve cable adjustment, poorly designed cheap shift kits, power exceeding the capability of the torque converter, which causes ballooning, and even having an improper flex plate. It can also be caused by defects in the surface finish of the crankshaft, and that can be from either the factory after a rebuild. You can have hot spots or scratches from incorrect polishing after the initial grind. It can be from improper preload, using the wrong bearing, or failure to follow the tightening procedures after a rebuild, using the wrong bearing. That could be if you had the crank ground down, then you use a standard bearing instead of an oversized one. Finally, it can also be caused by improper alignment of crank-driven accessories, such as power steering, AC compressor, whatnot. So what happens when that bearing wears out is the crank is allowed to move side to side. And this is easily verifiable, at least in the advanced stages. You don't have to tear anything apart. All you need is a screwdriver or pry bar, and you get in between the balancer and the block, and you pry on it. And if the crankshaft moves visibly, or you hear a clunk, it's obviously bad. It can be more subtle. Sometimes you have to tear it down before you find out, but usually the symptoms will give it away. And obviously you verify it more technically using a dial indicator, and we'll go over that in a future video where we go over how to assemble a short block. So, just an example of what happens with a bad thrust bearing is, you'll see scratching, a little bit flattening out. And in severe cases, what will happen is you'll end up with a piece of the bearing in the oil pan, such as what happened with this Toyota block here. Now, when you're assembling an engine, and you got a fresh motor, and you check with your dial indicator what the preload is. Normally on most engines it should be, within a few thousandths of an inch. And that's why when it's bad, you can visibly see the crank move when you pry on it. you're clearly past a few thousandths of an inch. But if you have excessive end play on a fresh motor, it's usually due to improper block or crank machine finish, wrong bearing size like I described before, or having a main cap cocked to the side from tightening it improperly. Now, you can also have a problem with too little end play, and that'll actually cause the crankshaft to bind, and that'll lead to just catastrophic failure of the motor. Now, crank walk is more common on some engines. It's very common on 7-volt DSM motors. It's also really common on engines that use a two-piece circular design. See, on some engines, the main bearings will be the thrust bearings will be located on either side of the girdle. On other ones, there will be one down in the girdle and one above in the main cap. So what happens is when you get a little bit of wear from whatever reason, the chamfered edge here becomes very easy for one to slide over the other. And at that point, bearing spun, falls out of place, and that's when you start having more severe symptoms. But I think that just about covers it. So stay safe, and I'll catch you in the next video.